Hello students, welcome to the Interesting Chemistry where you will enjoy a classroom teaching from your study room. In my previous video I have explained you about the atomic size, covalent radius, ionic radius, van der Waals radius and isoelectronic series. I hope that you have watched that video and I will also provide you the link of that video in the description box of this video. So now today I am going to explain you the ionization enthalpy or the ionization potential. Both the terms are similar. So ionization potential, this ionization is related to the forming of cation or positive charged from an atom. The ionization is totally related with the formation of the cation from an atom. So in an atom, the electron is attracted by the nucleus, you know very well. Then how will you remove an electron from an atom to form a cation? It means you have to give some energy to the atom. That energy will remove the electron from that atom. So here I am telling you, suppose this is an atom, an atom, and you provide this atom the I1 energy. So the atom converts into the cation M positive due to the removal of one electron. This energy is essential to remove the electron from an atom. So only this energy is enthalpy. The change in this energy of the system is enthalpy or the ionization potential. So if you want to define the ionization enthalpy, then you can write the energy required to remove an electron from an isolated gaseous atom, in the ground state. This is the definition of ionization enthalpy, in which I have used the isolated gaseous ground state. Do you know the isolated gaseous atom? It means the atom is in the form of gas. These are the atoms in the form of gas, and these all atoms are isolated. These atoms are not interacted with any other atom. This atom doesn't attack this or this or this. It is an individual. It is isolated in the gaseous atom, you know. So the isolated gaseous atom. Second one, the ground state. Ground state is called the normal state of an atom is called ground state. If you provide some energy to an atom, the electron of that atom will get excited. They will acquire their place in the higher energy level, that state called as excited state. So, in the normal state, when you provide, there is no energy on the normal temperature. That is called ground state. So again, the energy required to remove an atom from an isolated or a gaseous state from an atom in ground state is called ionization enthalpy. So again, this when you remove one electron from an atom, that is called the first ionization enthalpy. This is ionization, first ionization. This one shows the first ionization enthalpy. This energy is ionization potential, and this energy is equal to the ionization enthalpy delta 1H. Now, from that single positive ion, you want to remove the second electron, then again you have to provide some energy to that ion. So that's why, suppose you I2, then the second electron is removed. So this enthalpy, ionization enthalpy delta 2H. And again the third electron delta 3H. I think that you have understood about the delta 1H, delta 2H and delta 3H. On removal of the subsequent electrons, first, second and third, you will require some energy to remove the electron from the isolated gaseous atom in the ground state. That energy called the ionization enthalpy or the ionization potential. Now compare these first enthalpy, second and third, first energy, which is greater? The I3, because I3 is greater than I2 and I2 is greater than I1. Because so delta 3 is greater than delta 2, delta 2H is greater than delta S. This is the comparison. Why? Now tell me that the comparison delta 3 is greater than delta 2 and delta 2 is greater than delta 1H. Why? Because I have written here, this is the atom, this is the size of atom. When you remove an electron from the atom, the size of the atom will decrease. The size of the atom will decrease, and the ENC, effective nuclear charge, will increase, because this is 281 sodium and it is 28. Now there are 11 electrons here, 10 electrons, so the ENC will increase. I have explained. Some students are unable to understand the ENC. I am giving the example. Suppose I am in class, there are only 10 students are there and I am watching them very clearly. Suppose now the number of students increases up to 50. So the last, I won't watch properly to the last students, last bencher students. My effect of watching is constant, but the effect of my watching will decrease to the last bencher students. In this way, that is called ENC, the effective nuclear charge. So the effective nuclear charge. So in this way, the size will decrease. So the to remove from this short, the size of this one, the size is this one, the M2 size is again come. So in this short, this is the shortest size, so you will require more energy than the I2, and I2 require more. That is the cause of the comparison of the first, second and third ionization enthalpy. I think that you have understood about the ionization enthalpy. These are the first, second and third. Now I am going to explain you the periodicity of the ionization enthalpy and ionization potential. Periodic trends. Periodicity. There is a periodic trend in the properties of elements found in the periodic table. Trend means if the properties are decreasing, then they are gradually decreasing. If the properties or the reactivity is increasing, the reactivity is gradually increasing. That are the trends found in the periodic table. I have explained you in the atomic size. In the atomic size, if the trends are always found across a period or descending a group. When we go across a period, this one is a period, this is size. The size of the atom of the elements will decrease when you go from left to right. So in this way, when the atom size is decreasing, so this is size. I'm telling you, this is size. It is size. But I am writing here delta H. The ionization enthalpy will increase because the size increase due to the ANC, effectively charged. So the size when size is decreasing, you have to give more energy to remove the electron, so the delta H will increase. On the other hand, in a descending group, this is the size of lithium, this is the size of sodium, this is the size of potassium, and this is the size of rubidium. The size is increasing. Hence the valency shell electron or the outermost electron is attracted by least attraction of the nucleus. So that electron can be easily removed from the atom by giving a small amount of energy. So delta H will decrease. I have written in this. When you go in this periodic table, the delta H is decreased. Enthalpy, ionization enthalpy decreased, and when we go to left to right across a period, then the delta H will be increased. This is the periodicity of ionization enthalpy. Now I am going to explain you from this here. I have given you two examples. That this is boron, this is beryllium. I have told you that the delta S is increasing. So the delta H of boron is more than the delta H of beryllium according to the periodicity, according to the trend of the delta H. In the same manner, here the delta H of N and the delta H of O. So the delta H of O is greater than delta H of N. I have written delta H of N. But these are correct. Both these statements are incorrect. Sometimes you have been asked in your examination, why it is so that the delta H of beryllium is greater than reverse it. Then you have been asked that the delta H of beryllium is greater than delta H of B. In the same manner, the delta H or the ionization enthalpy of the nitrogen is greater than 10. So I have explained you, according to the trend, according to the periodicity, they should be in this way. But in practical, we found reverse of this statement. How will you explain? So go to the, so first I will explain you the factors. I have explained the periodicity, the factors affecting the ionization, IE means ionization enthalpy, and IP, ionization potential. Factors affecting. These factors are the atomic size. I have written here the atomic size. I have shown with the arrow that this arrow is going to upward. This arrow is going to upward. It means size is increasing. This arrow is going to upward. It means size is increasing. So the on increasing of this size, delta H will decrease. I have written here. Delta H is decrease on this side, on increasing. Please note it, this chart I have written here. So the atomic size, the size I have written in this way. It means this is arrow shows us the increasing the size. When size increase, the delta H will decrease, or reversely, when the size of the atom decrease, so delta H will increase. Both the size and the delta H both are inversely proportional. Size and delta H both are inversely proportional. So never confused about it. Now I said ENC. If the ENC increases, it means the attractive power of the nucleus increases. So the ENC will attract more powerfully to the electrons, and you want to remove the electron, then the energy, the required energy will be more. So the delta H will increase on ENC. On ENC increases, delta H increase, ENC decreases, delta S decrease. Now the shielding effect. Shielding effect always decreases the delta H. What is shielding effect? This is nucleus. This is the internal cell electrons. This is the outer. This is the outer. And these electrons will repel to this outermost electron. The electron that is found in the outermost cell, or the valency cell electron. So the ENC will decrease. Hence, the shielding effect causes the decrease in the ionization enthalpy. Again, the penetration of the orbital. Penetration of the orbitals. What do you mean by penetration of the orbitals? I think that you have understood about all. I will remove this. And penetration. Penetration relates to the size of the orbitals. The S is round, P is dumbbell, and PSPD is double dumbbell, and D or complex. Let's see about it. This, the electron cloud revolving found in the S orbital is symmetrical. This is symmetrical. So the attraction of this nucleus to this electron cloud is more than any other. It is symmetrical. So it will attract more with more force, with more power. So the size will go. And now here this is the dumbbell shape, and nucleus is here. Do you ever visualize this structure? This is dumbbell shape, and here I have shown you the nucleus. How can it possible? So please always visualize this function. This is the p orbital is elliptical. Suppose this is the p orbital, it is elliptical. So when you take it like this, the shape of the p orbital will be dumbbell shaped. This is the path of the electron that will revolve around this structure. But there is a difference in the both this path here, where I am showing you the place of my two fingers. This is the place of the nucleus. So here, in this way, when you will find, you will draw this diagram in this way. You will draw this diagram, but there is a space between this way of the orbital way. So I can write here. So please always visualize this. Okay, you can write here the nucleus in this way. So this is here in this case. If the electron is here, you can easily remove this electron from this place. And this electron have similar attraction in all direction. But when this electron goes here, you can remove it from here. And this will, when this electron goes, it means the shape of the SPDF depends the penetration. So the penetration power of this is more. So in this case, when you remove the electron from s orbital, the value of delta S will the shielding effect of penetration. So penetration is S. Due to the penetration of the shape of the s orbital, the delta H will be more than P, and the delta H of the P will more than D, and so on. It is the grading. It is the comparison of the SPDF penetration. So I will explain this question. The boron, according to the periodicity, the boron, the delta H of borons should be more than delta H of beryllium. So right here, see here this is boron number 5, and this is beryllium number 4. You will write here 1s2, 2s2. Boron, it is 1s2 and 2s2 and 2p1. 2p1. So only I am telling you about the first delta 1H. Please also correct it. Only I am talking about the first ionization enthalpy. So here the first in boron, the first electron is removed from P, and in beryllium the first electron is removed from S. So the penetration power of the S is greater than the penetration power of the P, as I explained in this way. In this way, you can say the delta 1H of beryllium, delta 1H of beryllium is greater than delta 1H of boron. This is due to the S. I explained you. I will give you some more example in my coming video, but here I have given you this example. Now the last factor affecting the ionization enthalpy and ionization potential, that is shielding, that is the penetration, and the last fourth one, P3, D5, F7, P6, D10 and F14. What do you mean by this bit? These are the half-filled and full-filled orbital. So the stability of the half-filled and full-filled orbital is more than any other unfilled orbitals. I have divided 3. P2 is unfilled orbital, P3 is a half-filled orbital, P6 is full-filled orbital, P4 is unfilled orbital, P5 is unfilled orbital, but P3 is half-filled orbital, and P6 is full-filled orbital. So the stability of the half-filled and the full-filled orbital is greater than any other unfilled orbitals. So in this case, now think about, I have given a special video on the stability of the half-filled orbital. So please watch that video. So here I want to explain you this question, that the delta 1H or the delta 1H of nitrogen. This shows according to the periodicity, the delta 1H of oxygen, or I mean to say the ionization enthalpy, first ionization enthalpy of oxygen should be greater than the first ionization enthalpy of the nitrogen. Because the nitrogen is on 7 number, oxygen is on 8 number, so enthalpy is increasing. So this nitrogen should have the enthalpy, lower enthalpy. Oxygen should have higher enthalpy according to the periodicity. But in practical, it is found that the delta 1H of nitrogen is greater than delta 1H of oxygen. It is right and it is wrong. So I have reversed this value again here. So nitrogen, how will you explain? Come to the nitrogen number 7. 1s2, 2s2, 2p3, 2p3. Oxygen O8, 1s2, 2s2 and 2p4. 2p4. So the first ionization enthalpy, the first electron from nitrogen oxygen in nitrogen will be removed from P3, and in oxygen in O8 the first electron will be removed from P4. This is unfilled orbital, this is half-filled orbital. So the half-filled orbital is more stable than the unfilled orbital. So the removal of one electron from the P3 will require more energy. Hence the enthalpy, first enthalpy of the nitrogen will be greater than the first enthalpy of the P4. I think that you have understood about the factors affecting the size, effective nuclear charge, shielding effect, penetration effect, and on the half-filled and the full-filled orbital. Now I am coming to the application. On removal of electron or the capacity of donation the electron. The elements who donates easily electrons are called metals. The elements who forms easily, who converts easily in the positive ion, that are metal. Who donates or who loses electron, that are so easy. So the enthalpy in the electron here, the metallic in the periodic table, lithium, sodium, potassium, in the here oxygen, chlorine. So the metallic, the ionization enthalpy is directly related to the metallic properties. Delta H, delta 1H. Suppose delta H, I am writing only the ionization enthalpy. If delta N increases, so the metallic properties metallic properties will decrease because enthalpy increases, so the removal of the electron requires more energy, so the metallic character will decrease. In this way, the enthalpy, you found the enthalpy of this lithium sodium bond is the increasing delta H, so the metallic properties will decrease. So the delta H and the metallic properties are inversely proportional. As the ionization enthalpy increases, the metallic properties will decrease, and if the ionization enthalpy decreases, the metallic properties will increase. So in this way, these are the inversely related. I hope that you have understood this video, understood this all about the ionization enthalpy, and I have given you 2 examples. So please go through this video from starting to the end. It's a very useful video for you. Sometimes the half or the half mark or the 1 mark of the question have been asked in your examination. So please do share this video to your friends. This video is for those students who cannot join with you in the coaching or any other facilities. Those who are preparing from the rural area, from their home, please share with them. It's my aim to forming this video. So that's all for today. Thank you very much.